Okay, all right, children, welcome back again to the new physics session today. So, in today's lesson, we are going to learn about uh, cause of refraction. Okay, why refraction takes place. So, in the last session or in the last video lecture, I've explained you that whenever a ray of light travels from optically rarer medium to the optical denser medium, the ray of light gets deviated, or you can say it bends towards the normal, isn't it? And similarly, when a ray of light is traveling from denser medium to the rarer medium, the light rays gets bent away from the normal, or it gets deviated away from the normal, isn't it? Now today we'll see why does this happen. So in the last video lecture, I said you that the reason for the bending or the change in the path or change in the direction of the path of the ray of light when it travels from one optical medium to another optical medium are explained in the next or in the upcoming topics I said, isn't it? So today I'm going to explain you, okay, cause of refraction, okay, cause of refraction, okay, or cause of change in direction. Why does this happen? So when a ray of light passes from one medium to another medium, its direction or path changes because of the change in speed of light in going from one medium to another. So the reason is the speed of light is different in different medium, isn't it? So in the last video I said you that light has maximum speed in the vacuum or in the air, and that is 3 into 10 to the power 8 meter per second, isn't it? And in water the speed of light is how much? 2.25 into 10 to the power 8 meter per second. Similarly, in glass the speed of light is 2 into 10 to the power 8 meter per second. So here you see that if you compare air and water, water is denser as compared to air, so hence its speed of light decreases in water. Similarly, when you compare water with glass, glass is more denser as compared to water. Are you getting my point? So the speed decreases and now it becomes 2 into 10 to the power 8 meter per second. So with this three speeds, we can analyze that the speed of light decreases as it goes from one medium to another medium. So it means that if the medium is denser, if the light ray is traveling from rarer medium to denser medium, speed will decrease, and this change in speed actually causes the direction or the change in the direction of the path of light when it travels from one medium to another medium. For example, if I take one medium two media, that is air and glass here, so this is the surface which is separating my air, medium 1 to medium 2, that is glass. So if the ray of light is incident from the air towards the glass, what happens if I draw the normal here? This should be the actual path because light travels in a straight line path, isn't it? But since now the light is traveling from air towards glass, that is from the rarer medium to denser medium, speed of light here decreases, understand? So when it decreases, it bends towards the normal, so this will be the refracted ray. So this change in direction of the ray of light when it passing from one medium to another medium is due to the change in the speed of light. So now you must remember that when the ray of light is traveling from rarer to denser, speed of light gets decreased. Light ko speed घट्छ, त्यो घटेको कारणले गर्दाखेरि चाहिँ what happens, it changes the path and it bends towards the normal. So normal पट्टि चाहिँ के हुन्छ, ढल्किन्छ. Alright, so when I compare angle of incidence here and angle of refraction here, what happens? Angle of incidence becomes greater than the angle of refraction. So this is one situation. Now similarly, if I take two medium, one is glass and the other one is air. Now the incident ray is traveling from glass towards the air. It is traveling from glass towards the air. This would be the original path of the ray of light. Okay, now since here you see that the the light is traveling from glass to air, that is from denser to rarer, what happens? Speed of light in the air increases or becomes more as compared to speed of light in the glass. So what happens? The ray of light bends or moves away from the normal. So this becomes my angle of refraction and this is my angle of incidence. So at this case my angle of incidence becomes less than angle of refraction. So here with this you can conclude here that whenever a ray of light is changing or traveling from one optical medium to another optical medium, speed gets changed or there is a change in the speed of light, since speed of light in different media are different or is different, understand? So when the ray of light is traveling from rarer to denser medium, what happens? It bends towards the normal, making angle of refraction less than the angle of incidence. Similarly, when a ray of light is traveling from optical denser medium to optical rarer medium or rarer transparent medium, speed of light increases and hence what happens? The ray of light travels bends away from the normal and thus in turn makes angle of refraction greater than the incident ray. All right, so now I hope you have understood the reason behind the cause of refraction. So refraction takes place or the change in the path takes place. Why? Because different medium, in different medium the speed of light is different. Okay, so now let's move to the next one. Now we have laws of refraction. So now you have learned about laws of reflection in class 9 part 1 book, isn't it? There were two laws. In those two laws we had that angle of incidence, the incident ray, the reflected ray and the normal lie on the same plane at the point of incidence. And the second law of reflection was that angle of incidence equals to angle of reflection. Those were the two laws based on reflection. Now since we are doing a refraction, so refraction also has two laws, understand? Number one is the incident ray, the refracted ray and the normal at a point of incidence all lie in same plane. It means, see, I have said you in the last class that refraction is a surface phenomenon. The bending of a ray of light when it travels from one medium to another medium always takes place at the surface separating the two mediums. So if I have a rarer medium on the upper part and a denser medium, say glass, in the lower side, then what happens? Here, if this is my angle of incident, incident ray, AO is my incident ray. So this O is the point of incidence, and here I have drawn the normal. So normal is also passing at the point O, understand? And from the point O itself, what will happen? The refracted ray will emerge out or will begin. So here, this first law of refraction, the first law that we have mentioned here, I have mentioned here, it says that the incident ray, this is my incident ray, then normal, this is my normal, and the refracted ray, this is my refracted ray, at the point of incidence. See, all of them are here at the point of incidence, that is O, and all are lie in the same plane, Odai plane. Now same plane does means like this. See, if incident ray is here, it's striking here, it doesn't mean that the refracted ray will come somewhere below that surface separating the two media or above the surface separating the two media. It has to come from or emerge from the same plane and from the same point on which incident ray is striking on the surface separating the two medium. All right, so this is the first law. Second law of refraction, or the next law, you can say, you cannot say first law and second law, you can write in either way also. You can write this law first and then write this law in the second number. It doesn't matter. That is not the concept here. Now here the second one, the other law says the ratio of sine of angle of incidence that is I. So I is the symbol or the abbreviation which is used to indicate or represent the angle of incidence. Okay, to the angle sine of angle of refraction, that is R here. Okay, R is constant. It is constant, it is fixed, it does not change for a given pair of media. Okay, that is mathematically sine I, okay, by sine R equals to constant. What is it? It remains constant for a given pair of media. For example, if the pair of media is air and glass, okay, air and glass, then for this given pair, this ratio of sine of I to the sine of R is always constant. So this is what the second law says. This law is also called as Snell's law. So this law, like what we call it, the other name given to this is Snell's law. All right, are you getting my point? Okay, so now I'm going to show you where is your angle of incidence and where is your angle of refraction. Okay, so your angle of refraction, angle of incidence lie here. Okay, so this is the surface which is separating the media, okay, air and glass. Okay, so now if this is my incident ray and this is my normal, this angle, the angle formed by the incident ray, see, you must remember, see it properly, watch it properly. This is my incident ray. Your incident ray normal, your normal le banako angle like say I call angle of incidence, represented by I. Okay, similarly the ray which is coming out or passing in the second medium, that is glass, okay, that is called refracted ray. Your refracted ray and this normal le banako your angle like say called, we call it as angle of refraction. So sine of angle of I, okay, sine of angle of I, so something to do with trigonometry, divided by sine of angle of refraction, that is R, is always constant. यसको ratio चाहिँ जहिले पनि के हुन्छ भने constant हुन्छ रे, but condition is given that this constant is for the given pair of media. So air र glass मैले लेखेको छु भने चाहिँ यो दुईटाको चाहिँ के भयो, यो ratio चाहिँ constant भयो. All right, are you getting my point? Okay, so these were the two laws, okay, on which refraction depends. Your constant lie, we also call it as refractive index, which we are going to learn in the next class. Okay, refractive index lie represented by a Greek letter called mu. Yo micro भनेर use गर्थ्यौं नि हामीले things उसमा prefix, okay, smaller units ma use गर्छौं micro भनेर, that is called mu. So this is mu, but here in this chapter this mu represents refractive index. All right, now we are going to learn the effect of speed, effect of wavelength and frequency, okay, due to refraction of light. So refraction हुँदाखेरि चाहिँ, when refraction takes place, okay, means when light is traveling from one medium to another medium, what happens to the speed of the light, what happens to the wavelength of the light, and what happens to the frequency of the light. That is what we are going to learn now. So number one, here we have, when a ray of light gets refracted from rarer medium to denser medium, the speed of light decreases. We have already learned this concept, isn't it? Whenever a ray of light is traveling from rarer to denser medium, okay, rarer to denser medium, speed of light decreases. While if the refracted ray, while if it is refracted from denser to rarer medium, so if the light is traveling from denser to the rarer medium, the speed of light increases. So that is why the ray was bending away from the normal in the above explanation, isn't it? So here we saw that the speed of light depends on refraction. If the refraction is taking place from rarer to denser, speed will decrease. Okay, if the refraction is taking place from denser medium to the rarer medium, speed of light increases. All right, okay, now let's move to the next, that is frequency. What happens to the frequency? Let's see. The frequency of light depends on the source of light. Now since frequency frequency is represented by small letter f, okay, of light depends on the source of light. So कहाँबाट चाहिँ light आउँदैछ? It depends upon that, whether the light is coming from the sun, whether the light is coming from the electric bulb or a fire or a tube light or a sodium vapor lamp. Okay, so source ma depend गर्छ. So that is why refraction does not affect the frequency. Remember, frequency of a light does not change after refraction. Speed change हुँदै थियो, घट्दै थियो, बढ्दै थियो, depends upon the thing or from and to which medium the ray is passing. Depending on that, the speed of light was increasing or decreasing. But here we see that frequency, since it depends on the source of the light, कहाँबाट the light आउँदैछ. So that's why frequency does not change after refraction or on refraction of light. Okay, now let's go to the wavelength. Wavelength is denoted by the Greek letter called lambda. This is how we write lambda. Now when light passes from rarer to denser medium, the wavelength decreases. What happens to the wavelength? It decreases. Now since light is a form of a wave, light travels in a form of a wave. So if I draw the wave pattern here, if this is my wave, this length, the length between the two consecutive wave is called wavelength. So your wavelength चाहिँ के हुँदो रहेछ? Decrease हुँदो रहेछ. When the ray of light is traveling from rarer to denser. Now when the ray of light is traveling from rarer to denser, speed के हुँदै थियो? Speed was decreasing. That is why wavelength is also decreasing. So in that way you can remember. Understand? So here I have written within the bracket, since speed of light decreases, okay, but its frequency remains unchanged, but wavelength decreases. Now when light passes from denser medium to rarer medium, the speed of light increases and hence its wavelength increases. So speed गर्दाखेरि wavelength घट्दैछ, speed of light decrease हुँदाखेरि wavelength is also decreasing. Okay, so please remember in this way. Now number 4 is how can we derive or find the relation of the speed of light, that is v, wavelength of light, that is lambda, and the frequency of light, that is f. Yo tintaलाई चाहिँ how we can relate. So the relation to bring them together is v equals to speed of light equals to frequency multiplied by wavelength, that is v equals to f into lambda. Now how did we get this? So this again comes with your speed distance time formula. Okay, it's coming from speed distance time formula. So you know that speed, we have learned this in our class 9's book, part 1 book, as well as I hope you have learned this in mathematics also. Speed is given by distance by time. Are you getting my point? Distance by time. So here speed, we are talking about the light. So speed of light is represented by capital letter V equals to, okay, distance. Distance is the length of the wave. So length of the wave is denoted by lambda divided by time is denoted by small letter t. Now this I can write as 1 by t into wavelength, that is lambda. But you know that frequency is the reciprocal of time. So you can write f is equals to 1 by t. Isn't it? 1 by t. So 1 by t भनेको it's f. So here I get v equals to f into lambda. So this is the relationship between speed of light v, okay, to the frequency and the wavelength. Okay, so the product of wavelength and frequency gives you the speed of light. So one important formula to be remembered, and I'm pretty sure that I've taught you this in the chapter sound also. In the chapter sound also I've taught you this. Speed of sound equals to frequency into wavelength of the sound. Alright, okay, now let's see what we have in the next page. Okay, so that's all for today. So now here we have assignment. Okay, so now you can pause this video here and note down this 7 questions which I have given you as the assignment for today, which you have to copy, okay, and write the correct answers and solutions and send me in the evening as usual. All right, so that's all for today. Have a good day.